Close your eyes for a second. Picture the most famous tank in the world. The one that clawed through the Iraqi desert in 1991 so fast and so quietly that the enemy called it Whispering Death. The one that's been upgraded, bolted onto, padded up, and stuffed with tech for 4 straight decades, until it topped 70 tons of rolling, roaring steel. Now picture something different. It's midnight, no engine growl, no heat shimmer in the air, just a shape, low and silent, sliding across the ground like it isn't really there, until the gun moves and the target disappears. That is America's new tank, the M1E3 Abrams, and it's on a completely different level. To understand why the M1E3 is such a big deal, you have to understand what went wrong. For 40 years, the Abrams was the answer to every question. Enemy has a new missile? Add more armor. Crew needs better sensors. Bolt them on. Want more electronics? Find the space somehow. It was an engineering philosophy that made sense in the Cold War and completely hit a wall in the 2020s. By the time the Army got to the M1A2 SEPV4, the Abrams had ballooned past 80 tons. 80 tons! That's roughly the weight of 14 African elephants rolling down the road on tracks. Except at least elephants don't need a dedicated fuel convoy just to keep moving. And that fuel was the Achilles heel nobody wanted to talk about. The original Abrams runs on a Honeywell AGT1500 gas turbine. The same basic principle as a jet engine. It's powerful, it's loud, and it is thirsty in a way that would embarrass a Formula One car. In desert operations, fuel convoys became their own kind of military problem. Long lines of trucks on open roads, every one of them a target, all of them crawling under the sun to keep the tanks fed. Then Ukraine happened, and the Army watched very carefully. They watched cheap FPV drones, the kind you can buy online for a few $100s, hunt tanks worth millions. They watched how anything that sat still too long got spotted, targeted, and destroyed. They watched how weight became a death sentence on roads turned to mud, or bridges that couldn't hold a 70-ton machine. They watched Russia weld metal rooftops onto tanks to try to stop drone drops, actual barn roofs on tanks. And they understood exactly how desperate the old solutions were getting. On September 6th, 2023, the US Army made a decision. They killed the SEPV4. Dead. Closed out. Over. And they told General Dynamics Land Systems to start fresh. The marching orders? Build a tank for the 2030s. Not a heavier sequel to what already exists. Something smarter. Something lighter. Something that can survive a battlefield defined by drones, software, and signatures. Not just shells. That program is the M1E3 Abrams. And in January 2026, the world got its first real look at it. Not a computer graphic. Not a brochure. Actual hardware, unveiled at the Detroit Auto Show, driving and ready for testing. Let that sink in for a second. They showed a next-generation main battle tank at the same event where automakers show off electric pickup trucks. That is the message the Army is sending about what this thing actually is. Let's start where everything starts. The engine. For over 4 decades, the Abrams screamed. The AGT1500 turbine was unmistakable. You could hear it from a mile away. You could feel it. On cold mornings, crews would let it warm up for 20 minutes just to get going. It burned through fuel like a race car and ran hot enough to be a thermal beacon for any sensor looking for it. That engine is gone. In its place, a Caterpillar C13D diesel, inline 6-cylinder, 12.9 liters of displacement, up to 1,100 horsepower. And here's the twist. It's paired with a Sapa electric drive transmission, turning the whole setup into a performance hybrid. Think of it like this. The diesel is the muscle, and the electric motor is the intelligence. Together, they give the M1E3 something no Abrams has ever had before. Silent mode. Not quieter, silent. The crew can switch into electric-only drive, and the tank moves without the engine running at all. No roar, no heat plume. Just the sound of tracks on dirt, barely a whisper. In a world where drones use thermal cameras to hunt heat signatures from the sky, that is not a nice-to-have feature. That is the difference between being seen and staying alive. And the fuel savings are staggering, up to 50% more efficient than the current Abrams. That might sound like a statistic, but think about what it actually means in a real war. Half the fuel convoys, half the trucks on dangerous roads, half the supply chain exposure. Every gallon saved is a soldier who isn't driving it to the front in a truck with a target painted on the roof. There's a second power benefit nobody talks about enough: electricity for the future. Modern tanks are becoming rolling data centers. Sensors, radars, jammers, communications, AI processing, all of it drinks power. The M1E3's hybrid drivetrain produces enough onboard power to run all of that, and leaves headroom for directed energy weapons down the line. The Army isn't building a tank for today. They're building a platform that can absorb tomorrow. Now, the weight. The current Abrams, fully kitted out, can tip past 80 tons. The M1E3 is targeting 60 tons. That's a 20 to 30% reduction. Remove 20 tons from a main battle tank, and the world literally opens up. More bridges become crossable. More rural routes become viable. Air transport becomes possible where it wasn't before. In a Pacific scenario, islands, narrow roads, limited infrastructure, those extra options are everything. And this was done without giving up protection. The M1E3 uses advanced composite armor with modular depleted uranium panels, a V-shaped underbelly to deflect mines and IEDs, blast attenuating crew seats, spall liners, and automatic fire suppression. It got lighter because they redesigned smarter, not because they removed the stuff that keeps crews alive. Here's where things get genuinely futuristic. The M1E3 has an unmanned turret. The gun, the autoloader, the sensor mast, all of it sits up top with no humans inside. The crew, all three of them, sits in a heavily armored capsule in the forward section of the hull. That is a radical departure from everything the Abrams has been. The M1E3 carried 4 crew members: a commander, a gunner, a driver, and a loader. The person physically manhandling 120mm rounds weighing over 20 kilograms and slamming them into the breach. It was physical, exhausting, and essential. The M1E3 replaces that person with an autoloader. The machine does the lifting. The machine cycles the ammunition. The human focuses on thinking, not hauling. This does 2 enormous things. First, it removes a human being from the hottest, most exposed part of the vehicle. The turret has always been the most dangerous place to be. It's where missiles aim, where shaped charges focus, where the ammunition lives. Moving the crew to the hull puts them behind thicker armor with better blast protection. Second, it compresses the turret. No human means no space for a human. The profile gets lower. The silhouette gets smaller. A smaller silhouette is harder to hit, harder to range, and harder to track. That's passive stealth, and it's free. The autoloader also changes the rate of fire. Officially, the Army hasn't published numbers, but mechanically, a machine that never gets tired, never hesitates, and never drops around loads faster and more consistently than a human under stress. When rounds need to fly, they fly. The gun itself stays at 120mm smoothbore, descended from the M256 family. This is deliberate. The Army isn't chasing caliber. They're chasing smart ammunition. That M1147 advanced multi-purpose round that entered full-rate production in January 2025. One round that replaces 4 legacy types, programmable fuse for point detonation, delay, or airburst, pairs perfectly with the autoloader. The gunner selects the mode. The machine loads the round. The target ceases to exist. 1 shell, 4 missions. No fumbling in the dark for the right cartridge. If the engine is the heart and the gun is the fist, then the software is the brain. And in the M1E3, the brain got a complete transplant. The tank is built on a fully digital combat architecture, aligned with the US Army's Modular Open Systems Architecture, MOSA. What that means in plain English, the M1E3 is designed like a smartphone, not a safe. You don't replace the whole thing when you want a new feature. You update the software. You swap in a new sensor module. You push a patch over a secure link, and the fix is on the tank. For comparison, think about how the old Abrams worked. You'd identify a problem, write a report, start a procurement cycle, wait years, ship parts, send technicians. 3 years later, maybe the upgrade arrives at the unit. By then, the threat has moved on. The M1E3's answer to that is to make the upgrade cycle look like a software company, not a defense contractor. See a problem on the battlefield in Ukraine on Monday, push a software fix by Friday. The sensor suite matches this ambition. The tank carries 360-degree cameras, drone-detecting microphones, thermal sights, laser warning receivers, acoustic arrays, and AI-assisted threat detection that can flag a target before the crew consciously registers it. The gunner isn't staring at a blank screen hoping to spot something. The system is already telling them where to look and what they're looking at. And then there's the cockpit. Forget the old yoke and pedal setup that hasn't changed in decades. The M1E3 reportedly features a Formula One style cockpit, a game controller style yoke, digital displays, ergonomics designed for how humans actually operate under stress. The Army took one look at how fighter pilots and racing drivers manage information and said, yes, that's how a tank should feel. Surviving on the modern battlefield isn't just about what you're made of, it's about what never touches you. The M1E3 is designed to integrate an active protection system from the ground up, not strapped on as an afterthought, but wired into the nervous system of the tank from the start. The leading candidates are the Trophy Faye PS and the US Army's Modular Active Protection System standard. Here's how active protection works. Radars on the hull scan the air around the tank constantly. An ATGM launches from 400 meters. The radar catches it in flight in milliseconds. Before the crew even hears the warning tone, a countermeasure fires, a burst of kinetic projectiles that intercepts the missile and destroys it short of the tank. The crew never breaks rhythm. Against drones, it works differently. The counter-UAS layer uses the drone detecting microphones, radar signatures, and AI classification to identify a threat, cue electronic countermeasures, and if necessary, deploy hard kill defenses. In a world where a $300 FPV drone can kill $1 million vehicle, having that layer integrated, rather than bolted on, means it's always online, always calibrated, always part of the tank's thinking, not a separate system that may or may not be switched on. And the heat signature. The hybrid drive running in silent mode produces dramatically less thermal output. Less heat means less visibility on infrared sensors, the same sensors that every modern drone, missile, and targeting system relies on. The tank doesn't just hide from human eyes, it hides from the machines. Picture this, it's 3 a.m. in Eastern Europe, rain, mud, total darkness except for the faint blue glow of a tablet screen. A small drone team has been watching a crossroads for 6 hours. They pick up a thermal cluster, an ATGM team tucked behind a farmhouse, 3 men and a launcher, waiting for first light. The platoon commander sends a ping on the network. 2 M1E3s receive it simultaneously. They've been in silent mode for 2 hours. Electric drive, no engine heat, no sound except rain. They move. Nobody hears them. The gunner programs an airburst for the farmhouse corner. The autoloader cycles, 1 round. The air burst detonates above the ATGM team with surgical precision. The threat evaporates. A laser warning receiver spikes. Someone else ranged them from the tree line. The APS radar catches a streak of heat moving fast. The countermeasure fires. A missile that was launched 300 meters away gets swatted out of the air like a clay pigeon. The second tank selects a delay fuse. 1 round punches through a wall. Infantry flows through the breach. That sequence, from silent approach to breach, took 11 minutes. 3 men per tank. No loader. No wasted motion. Just code, steel, and precision. That is not science fiction. Every one of those capabilities is either already in testing or already deployed on the systems feeding into the M1E3. Let's be real for a moment. The M1E3 is a bet. A very informed, very expensive bet, but still a bet. An auto loader is more capable than a human loader under most conditions, but it's also more complex, and complexity breaks. When it breaks on a Tuesday morning in a muddy field, you need a technician, not a wrench. A hybrid drivetrain is brilliant for efficiency and silence, but hybrid transmissions have failure modes that a straightforward diesel doesn't. And a software-defined tank is only as good as its cybersecurity. Every open architecture that accepts rapid updates is also a surface that accepts rapid intrusion if someone gets through the door. These aren't reasons to oppose the M1E3. They're reasons to respect what the Army is actually trying to do, which is learn fast and fix forward. The reason 4 prototypes are already in soldier hands in 2026 is precisely to find those failure modes before they matter in combat. Iteration over perfection. Speed to learning over speed to PowerPoint. There's also the industrial dimension. The Lima, Ohio plant, where Abrams tanks are built, remains the only facility in America that makes this machine. That plant is being kept modern and capable as M1E3 development progresses, not just as a factory, but as a national security asset. When the program ships, it ships from Ohio, and the plant that learned on every generation of Abrams is the one that builds the next one. The Abrams was born in the Cold War, survived the Gulf, absorbed the global war on terror, and now it steps into an age where the most dangerous weapons might cost less than a used car and navigate themselves with a phone app. The M1E3 is the Army's answer to that world. Lighter so it can move, quieter so it can hide, smarter so it can adapt, and still devastating enough that when it decides you are the problem, you stop being a problem. Iraq veterans who first called the Abrams whispering death were talking about a gas turbine that was surprisingly quiet for its size. Imagine what they'd call something that moves in electric silence, invisible to thermal sensors, with a gun managed by a computer, and a shield that swats missiles out of the air. The original Abrams changed armored warfare. The M1E3 is changing what a tank is allowed to be. The king didn't retire, he just got a lot harder to hear coming. If this kind of analysis is what you're here for, hit that subscribe button. There's more coming. See you next time.